This video is going to talk about restriction endonucleases, also known as restriction enzymes. You normally find restriction enzymes within a bacteria. About 25% of bacteria do have restriction enzymes, and you can have a bacteria have one or up to 7. Now, scientists have discovered 230 restriction enzymes that have different DNA sequences. For example, echo R1 is a type. You have N3, SMA1. So these are all different types of restriction enzymes. And what do? They are molecular scissors. They go through a string of DNA and they cut at a particular pattern. They were designed to do this so that if foreign DNA came into the bacteria, it was able to cut it apart so that as a natural defense. What I'm going to do now is I'm going to write out a particular code of DNA, and I'm going to show you how a restriction enzyme would work. So TATC, GAA, and we're going to pretend this is just a piece of DNA. TTC, GGA. And this is going to run from 5' to 3'. And because DNA is complementary, I'm just going to draw its complementary base, its complementary strand. This is going to go A, T, A, G, C, T, T, A, G, C, C, T. Okay, this is going to be 5'. Okay, so we now have our DNA strand. Now, what our restriction enzyme is going to do, and let's just take this one here. So echo R1 is going to come through, and we're just going to make it be a blob. So this is restriction enzyme echo R1. And it's going to come through and it's going to look for a particular palindrome that is in that code of DNA. For echo R1, it's particularly looking for the sequence G, A, T, T, C. What does that mean? Right? So it's looking for that code, and that slash there shows you where it's going to cut the DNA. Echo R1 stands for the bacteria that it was extracted from and the type of restriction enzyme. So there are different types based off of different criteria that they have. And we're not going to get into the specifics of that. And then echo is short for E. coli. So this was extracted from E. coli, and it is type 1. So echo R1 is going to go through this line of DNA, and it's going to look for, so TATCG, finds that G, and then it looks, does it have the AATTC? It does. And so this restriction enzyme is going to break this sugar phosphate backbone. It's going to break through those hydrogen bonds. Oh, we went a little too far. And then it's going to break again through this sugar phosphate backbone. Right now, we have left with, so this would be one piece here of DNA. And then use this color. We are left with this piece of DNA. So imagine if you have a circle. And I've talked about this when I had my plasmid video. I can post that later. So let's say it's cutting open a plasmid, right? So you're going to just cut a hole in that circle, and you're going to leave these things called sticky ends. Here, this has no hydrogen bonds that it can bond to, right? Because they're all broken. So this would be a sticky end. Now, you do have some restriction enzymes that will cut clean through the DNA, and those are called blunt ends. So if you were, so for example, SMA1, that restriction enzyme is looking for the code CCC GGG. And so if we had a string of DNA, it would cut it clean through and you wouldn't be left with these sticky ends. You would just be left with a code on one side and a code on the other.